I now turn to two-stage models to capture ambiguity attitudes. First, I consider the exogenous case. This should not be confused with what happened in the Ansbach-Aumann framework, because there we also had an additional stage, but it only was an auxiliary tool to make things simple. It was not central interest for us. Now here, the EXA stage is used to capture and define ambiguity. So it's of central interest to us and of central interest in the modeling. So it's now a crucial part. I'll explain in the Ellsberg urn, the unknown Ellsberg urn, how it works. So we assume we have 100 balls, they are red-black unknown proportion. You will gamble, let's say you gamble on red, the ball drawn from the urn randomly, that has red color. So this is the gamble that you face. And then we are doing evaluation, and I'll use the following figure. First, we have uncertainty about the composition of the urn. There may be 0 red balls, 1 red ball, 100 red balls, 101 possibilities. That's the first uncertainty that we face. Then, given condition on that uncertainty being resolved, we get a situation of objective probability. If we know the composition of the urn, then we know the probability of red, so the probability of you winning the prize. So that's how we model. You see, this is two-stage. This stage captures your uncertainty about the objective probability, so your ambiguity. So that's how we do it here. Now, something more to say. When people work with this model, virtually always they assume that the uncertainty in that second stage about the composition of the urn can be captured in terms of probabilities. Well, they are not objective, so then let's call them subjective probabilities. But that can still be done. So that we can say the probability, there is some probability of the composition of the urn being that there are 57 balls red, for instance. We have such probabilities available. That's usually assumed. Then at this stage, you may ask yourself, what's the big deal here? Because if you have probabilities, it's just classical probability theory. Nothing new is happening. Well, some probabilities are subjective, but still nothing new, because we can just do calculation. For instance, in this situation, we can calculate the probability of getting the prize. We just take all these prior probabilities, we multiply them by the objective probability conditional on them, and then if we add all these things, we get the probability of you gaining $100. So this is just, nothing new is happening here. Well, still people bring in something new, and they do by this multiplication of probabilities that we did here. People often call it reduction of probability assumption. People give up on that. They do something different. They do a different evaluation. They do a backward induction evaluation using non-expected utility models. For instance, these lotteries can be evaluated, and it can be determined what the certainty equivalent of these lotteries is using any maybe prospect theory, rank band, or whatever non-expected utility you may want. Next, after these lotteries are being replaced by the certainty equivalents, at this stage we can do an evaluation, and we can again use a non-expected utility model to do so. If you do that, so that is backward induction, but if you do that using non-expected utility models, you do get violation of reduction of compound lotteries. You do have to give up on that. Well, people are willing to do that. What they get back is, you can do, for instance, when here you evaluate the objective probabilities, you can take some moderate model, maybe not very pessimistic, risk-averse, whatever you call it. But then in the evaluation here, you can do different things. You can bring in much more, I don't know if I could call it risk aversion, pessimism, prudence, whatever you call it, you can bring it in. And then, so that means that the objective probabilities are evaluated quite differently than the subjective answer, this ambiguous uncertainty. That difference can be taken to reflect ambiguity attitude, for instance, ambiguity aversion. So this idea has been around a long time, and already here are many papers that did it. Also recently, quite some others have studied it. So this is one way to go. Now, a remarkable special case results. I told you a moment ago, and for every stage you can choose any non-expected utility model you want and see if it gives you a good result. A quite remarkable special case results when the evaluation in every stage is still done using expected utility. At this stage, you may ask yourself again, well, then there's nothing new. Because if you just do the classical expected utility this manner and backward induction, then in fact you are satisfying reduction of compound lotteries after all. You're just doing classical expected utility, you're being ambiguity neutral, nothing ambiguity attitude is happening. However, people do bring in novelty because they use a different utility function in two expected utility evaluations. For instance, here in the first stage with objective probabilities, they may be using an almost linear utility function, very little risk aversion. But then in this stage, they may be bringing in a much more concave utility function, giving much more, well, I can't call it risk aversion, pessimism, or whatever it is. And that is a way that you can capture ambiguity aversion, can model incorporate it. So that for the unknown ambiguous situation, you behave more prudent, whatever you call it, than for objective probabilities. Now, this is analytically very convenient because you can always be using expected utility. You can use known computer programs, so that's quite nice. And many people have written about it. In fact, remarkably, there was a 1975 working paper version of the prospect theory paper that was published in 79. That working paper already contained ideas on ambiguity. The 79 paper did do it. They also decided to postpone working on it. But that paper already presented this model. So that's remarkable. Yeah, and Krebs and Porteus, 1979, is a well-known famous paper, although they interpret this as time attitude. They wanted to capture time attitude rather than ambiguity or anything, but they use the same mathematical formula. Several other authors use it. The name for this model is recursive expected utility. Now, there are pros and cons, as always, to these things. One pro of this approach is intuitive. People immediately think, yeah, ambiguity, I don't know the probability. I have uncertainty about the probability. So if you capture that in a second stage, people can immediately relate to that and say, yeah, this is about ambiguity. Also, in general, you have much flexibility about the models that you can use in the two stages. Although much flexibility can be a drawback because you want to also have predictive power. So then that special version that we discussed in the end, this two-stage recursive expected utility, in fact, that's quite tractable version. It's mathematically convenient. And I already said, you don't need new software. So that's very nice and surely increases the popularity of this approach. But there are some drawbacks. One thing is, of this whole two-stage approach, exogenous, is in many practical situations you don't have that available. Well, in Ellsberg urn you can refer to these physically definable events, the composition of the urns, but usually that's not possible. For instance, if you have ambiguity about inflation going up by more than 4% next year, I cannot imagine that you could define well-defined physical events such that conditional upon them, this would be an objective probability of the inflation going up by 4% next year. Such a decomposition usually is not available. So therefore, these models are not general ambiguity models, but they can only be used in very particular situation, Ellsberg urn, but not many other situations. So that's the first drawback. I wrote it here. The second drawback is that this backward induction assumption is questionable. In the Anscombe-Ammann framework I already discussed, I said for non-expected utility is very problematic. That holds the same here in this context. The third objection is for this two-stage expected utility model. Then you are only using functions that operate on the outcomes, probabilities you don't do anything with it or events. And that is this homeomorphic principle that you want your model to capture psychological processes, not all going on here. Ambiguity, uncertainty is more about events, how you feel about events, not outcomes. In this model, that the recursive expected utility model, the interval of outcomes that you consider, that determines your ambiguity attitude, and not the events. That doesn't feel intuitive. And you can already see immediately that you get empirical problems with it, because the prevailing empirical finding for ambiguity, let me only talk about gains, is this fourfold pattern that unlike the events of giving a gain, you are more ambiguity seeking than ambiguity averse. Only for moderate or high likelihood of a gain, you are ambiguity averse. So it depends a lot on the events, on the likelihood. These models absolutely in no way can capture that, because it is only determined by the outcomes. And likely, unlikely events, it does not matter for ambiguity attitude. So the main empirical finding of ambiguity attitude, these models cannot capture. Therefore, I think also for empirical work, they are not very well suited. I'm going to continue discussing a multi-stage model, but then endogenous. That will be in next recordings.